And I'm going to share the screen, so let me know if you can see that. Can everyone see my screen now?
Yes.
Okay, all right, good. Okay, so we're gonna go ahead review the unit 3. This one is from the Minded Math review, so it will be pretty similar to the test. Of course, the number will be different, and the order might be a little bit different as well. So you can see like the unit 3. Okay, so let's see what is the unit 3 include. If you look at the syllabus, right? The unit 3 will include chapter 4 and 5. Yeah, so if you have a chapter 4 video, is still that is because test 3, which is unit 3, include chapter 4 and 5. Okay, chapter 4 is the probability for the um, you know, the chapter 4 and 5, basically they talk about the probability. Okay, so chapter 4 is the probability distribution. Chapter 4 we only require one section basically. All right, and then chapter 5 you have a 4 sections, so basically this is only 5 sections totally in here. Okay, and you can see the unit 4, last unit is chapter 6 and 7. So chapter 6, you got 2 sections. Chapter 7, you got 3 sections. So again, it's only 5 sections. Even we cover 2 chapters, but we don't cover the entire chapter. So this one is only 2 sections. Chapter 7 is only 3 sections. All right. But I think the last unit, which is you're going to use especially for confidence interval, right? This one you use a lot of calculator, okay? So that is this one right here. Probability, you can also use the calculator as well for some of them, okay? But you can also learn how to use the formula, finding the values, something like that. So that is about you chapter units 3 and 4, right? So I hope everyone is already started unit 3, yeah, that way. Because we only have one more week there, so that is very short. Summer is really fast, okay? Good news and bad news. The good news is you're gonna complete one college level math, which is a really big deal, all right? Bad news is the time is really fast, okay? It's only 1 week, so you really, really need to concentrate. And also the drop day is by the 23rd, which is, by June 23rd, not 25th. Our weekend college drop day is a little bit different than the regular summer one, okay? All right, let's look at this one right here. So chapter 4 and 5, you a lot of time you also need to be able to read the table. And where is the table? Table is posted on the module, okay? You can download the entire table and the formula. So if you go to the module here, you have a key formulas which you can download, right? As I mentioned earlier, you can have all this page of the formula, all the formula for the test, okay? All the formula in here. And you can also download the table, which is probably easier to read. If you print out your own table, you can highlight that. You can, make a little bit of highlight, you know, if that help. Okay, so that's different. So this is the table in here. All right. So, and then also include some of the commonly used confident label is already in here. So when the confident label, of course, this is unit 4, okay? It's 80%, 90%, 95%, and 99%, or 0.99. The critical value for the G is already in here, okay? This one, you can also read it from the table here, but these 4 labels are the most frequently used. So if you have these 4 tables, you can use this one directly instead of going to find a table in the middle on your own. All right. So you can download all this table and print it out. I recommend you to print out all the table and the formula sheet, because when you do the lockdown, it won't let you open that again, back and forth. Okay, so that is the suggestion. All right, so look at this one right here, the probability. So you need to read the table in here, right? So the table here, this is the G-score, okay? The G-score, you have to know the G-score in order to read the table. So the chapter 5, especially chapter 5 probability, is very easy to find. If you have a normal or approximate normal distribution, that means it's a bell curve, okay? So the bell curve here, you will have this kind of bell curve, okay? So normally distribution, you have this bell curve, and this is the G-score. If you don't have a G-score, you have to use the formula to calculate, okay? G-score in the middle, this is 0, and then 1, 2, 3. In here to the left is negative, okay? So G-score can be positive, can be negative in here. If you look at the table, if you look at the default table, go ahead, open the table in here. If you look at this table, you look at this legend, okay, this is the area to the left. All right, so whatever you read this G-score table is always the area to the left. If you read like a G-score is negative 2.69, right? If this G-score is negative 2.69, you read a negative 2.6 here, read the last digit from the top. So this is a G-score equal to negative 2.69, and the area is always positive. So with the area under the bell curve is also the same thing as the probability or the percentage. Okay, so this area represents 3 things. One is the area, second one is also represented the probability. Third one is also represented the percentage, right? The entire bell curve, total area is 1. Or 100%. 100% is 100 divided by 100, so it's also equal to 1. Okay, so you can use the percentage or you can use the decimal point in here. And the bell curve is symmetric, so that means the left side and the right side are the same. Okay, so each left side is 0.5, right side is 0.5, something like that, right? Okay, so let's look at our question here. This one telling you the G-score here is negative 0.62. So what is the probability? So this one is area to the left, right? If you read this one, means area to the left. So that means I only need to read the table, okay? So go to the negative. G-score can have a positive or negative, so you have to be very careful, right? Negative 0.6. So this is right here, negative 0.6. And then 2 going to the very top. 2, that's right here. I like to use my own table. Look at it. I use my own table. I can highlight that is easier. Okay, negative 0.62. So that's negative 0.6, and then 2 is on the third last. So negative 0.62. So that is 0.2676. Okay. On 2676. So that is the probability in here. Okay, so that's it. That's how you read a table. All right. And if you want to read a table, the area under the standard normal distribution to the left. Okay. All right. So if I want to find this area, this white one, not the green one, I want to find this area to the left. What do I do? Well, every time you read a table, is always area to the right, okay? And if you want to find an area to the left, you will subtract from 100%. All right. So the first one, we have this area to the left. Okay, area to the left. We do that is 0.2676. And I want to find the area to the right. Okay. So this area, this white area to the right, are we using 100% or using 1 minus 0.2676? And that will be 0.9, I'm sorry, will be 0.7324. Okay, or you can use a calculator. I'm just subtract by head. All right, so that's the area to the right. Okay, area to the right in here. So if you want to find the area to the right, you cannot read it from the calculator. You just subtract from 1. Okay. All right. Want to indicate probability and interpret the result. Okay, from 75 to 2020, the mean annually gain of the Dow Jones Industry Average was 652 points. Okay. Random sample of 34 years is selected from the population. What is the probability that the mean gain for the sample between 500 to 700? Assume the sigma is 15,1539. Okay, 1539 in here. Okay, so the probability is 1 to 4 decimal places, right? And you want to interpret the result, select the correct choice to fill out the answer to complete the choice. Okay, how many percent of the sample of 46 years we have an annual gain? This radio button, you only choose 1. Okay, when you have a radio button, it's only 1 correct. Okay, and about how many percent of the 34 years, this is 40, annual gain between 500 to 700. All right, so you will have to read the question very carefully, right? The mean annual gain was, so that's the X bar. Okay, so let's write down whatever we know. Okay, so write down the known. So X bar was, we have a 1975 to 2020. Okay, and annual gain was 652. Okay, a random sample, which is n is 34, right? A random sample of 34 years is selected from the population. Okay, what is the probability? Okay, so what's the probability of the mean gain for the sample was between 500 to 700. Okay, so we can do a little bit of bell curve in here. Okay, assume the sigma is 1539. So first you have to find the probability, right? So how do you find the probability? You have to find the probability first before you can choose the answer. Okay, so in this case, if you want to find a probability, you have to know the G-score, okay, because you have to read the table. And how much is the G-score here? Well, G-score here, you will need to use what? Go to look at the table, not the table, formula sheet, okay? So go to the formula sheet. The reason I want to show you the formula sheet so you know where to find your formula. That's the formula. Okay, let's open. I've got too many tabs. All right, so we have this formula sheet in here, right? So you go to find your G-score formula. Okay, so that is your G-score formula. Okay, the simple one here is x bar minus mu, x minus mu. The G-score using the data value minus the mean, right? Divided by the standard deviation. Okay, but if you have an n in here, which is the standard, when n is greater than 1, you have to use this one. This one is using for the n equal to 1. Okay, n equal to 1, you don't have to divide by the square root of n. Okay, but if you for n greater than 1, you have a sigma of the x bar is equal to sigma over square root of n. So now you have to have this formula. All right. So this like our n is 34. So we're going to have to use this formula. Okay. All right. So now we know which formula to use. G is x bar minus mu over sigma divided by square root of n. All right. So we have a mu here. Well, actually, this should be a mean, right? The population standard deviation. This is a mean. And then we're going to have an x. All right, so this one is x. We're going to have to convert it into G-score. Okay, so how do I convert it into G-score in here? We have to... Okay, so the average is the average standard, the industry average was 652, right? And you want to find the probability, the mean gain for the sample between 500 to 700. So that is the, we have a 500, okay. Our mean here is 652. And then we're gonna need to find between 500, which is less than 562, right? And then 700, which is greater than 652. So basically, we want to find this area or the probability, okay? This area in here. So if I convert this into G-score, convert this X value into G-score, right? So my G here in the middle is 0, and then let's see how much is 500 corresponding to G-score. Okay, this will be negative. This one on the right-hand side, so this will be positive, right? So we need to go to find a 2G score, okay? And the reason we're using the 2G score because the first one, so G1 using 500 minus the mu, 652 over sigma is 1539 divided by square root of n, which is 34. You go to find the first G score. And then you find a second G-score, which is using 700 minus 652. Okay. And then we go to find a 2G score. And then we will be able to calculate the 2G score, right? And then we find the two area. So how do you find the area in the middle? The first G-score, this is the area to the left. The second G-score is also from here all the way to the left. Okay, so you're using the big area minus the small area will be your area in the middle, will be this area in the middle. Okay, so we talked that earlier. How do you find the area to the left? Okay, area to the left is you reading the table, your area to the left. If you want to find the area to the right, you're using 1 minus area to the left, right? But if you want to find the area in the middle, we need to have a two area, area 1 and then area 2, and then using area 2 minus area 1 will be area in the middle. Okay, so that's exactly what we have in here. So you can using the calculator calculate this 2G score. Okay, and I'll show you the calculator later on. All right, so let's see. We have a G-score. Okay, make sure you use the parentheses, okay? We have a 500 minus 652. Divide denominator, you also need a parenthesis because you have a two number right here, all right? If you don't use the parenthesis, your answer will be wrong. Okay, so for the G-score table reading, we usually only run to 2 decimal points. All right, so this is negative 0.575. So I round up, so be negative 0.58. All right, because our table, you can only read 2 decimal points for the G-score. All right, and then this one right here, you use 700. Oh, mistyped one of them. Oh. Second x squared is the square root, right? Okay, you cursor up and then you close the parenthesis. All right, so this one is positive, right? So you round to 2 decimal point. The third digit is 1, so you round it down. So that should be only 0.18. All right, so that is your probability in here. Is your G-score. So this is negative 0.58. This is positive 0.17 for the G-score. So you will need to convert the X value into G-score using the G-score formula. All right. So now we are going to read the two areas. So area 1, so this one, G1, it will corresponding to area 1, right? Area always positive. Even G-score is negative. Area always positive. So we look at the table. Yeah, there you go. And open the table. All right, so I have my negative. So this is another good time to train yourself on how to read the G-score, right? So negative 0.58. So I have a negative 0.5. So go to negative 0.5 right here, right? All right, negative 0.58. So you need to read the up one to see where is the 8, okay? So that's the second one. So the area will be 0.2810. 28. So 2810. So that's the area, the A1 right here. Okay, this is A1. This is A2. All right, we're gonna go to read the A2, which is G-score is positive 0.18. Positive. So you have to come down here to have a positive 0.1. 0.1 in here, right? And look at the positive and the negative table. The G-score table is a little bit different. This is start with 0.012345 in here, right? On the negative one, this is 0.09, 0.02. So it's a little bit different order. So just make sure you always read the depth and the top. All right, very carefully. Don't assume anything. Okay. So that's 0.5714. 5714 on 5714, right? Let's make sure. Okay. All right. So now we're gonna find the area in the middle. So area in the middle, we're using A2 minus A1. So that's 0.5714 minus 0.1850. And then you just go to using the calculator to do the calculation. Okay. 0.5714 minus 0.2810. All right, so I have a 0.2904. All right, or you can convert it into percentage if you want to use the percentage. Okay, so that is how you find the area. So probability of the score, the Dow Jones Industry average between 500 to 700, between the probability would be about 29.04%. Okay, in this case. All right, and then you can go to choose whatever the corresponding answer in here. All right, so that is how you find this type of probability. Okay, number 3 is trying to see what is a discrete probability? Discrete probability is in 4.1. Okay, so what is a discrete? Discrete is something you can count, right? And then we want to find this kind of probability. So you have to know the concept. What are the two conditions that determine the probability distribution? Okay, and what is the discrete probability? Yeah, this one is choosing the correct answer, right? So what is the probability distribution in here? So if you look at A, the discrete probability distribution, list each possible value a random variable can assume together with its probability. So that looks like about right. Okay, and what are the two conditions to determine the probability distribution? Choose the correct answer. You can, if you do not know how to answer this one right here, you can also look at the key formula for the discrete probability distribution in here on chapter 4, right? So the mean of the discrete probability here is using sigma of the x times the p of x. So x is the data value, and then the p is the probability. All right. So that is basically determine the variance is using the x value minus the mean, okay, and then times the probability. So you can look at this formula and you can say, well, the probability is always between 0 and 1. That's for sure. It doesn't matter the discrete or the continual probability. That all the probability are between 0 and 1, right? We don't use negative number for the probability. Inclusive, it includes 0 and 1. And this is the key. The sum of the all probability is equal to 1. Yeah, in one table. So that is look about the right one. Okay. The sum of the all probability equal to 1. All right. So those are the probability in here. It didn't really say what influenced the probability, but just the general definition for this one. The standard normal table or technology to find a Z-score corresponding to the cumulative area is 0.101. Okay, so you can use this one. You can using the table, or you can using the calculator. I will show you how to use calculator because it's a little bit easier. But before that, I can show you the table first. Okay, so let's see. This one is kind of a little bit what? Read the table backward. All right, you want to find a Z-score. Remember, if we using the Z-score table, all right, let's go to look at the table here. Okay, if we know the Z-score, right, read the table, Z-score is done up very orderly. So from 0.1 to 0.9 and 1.1, very orderly in here. So when you know the Z-score, you want to find the area, is really easy because Z-score is so organized. But this one is also organized, but a little bit harder to find, okay? Because now you have a cumulative area is 0.105. So what does that mean in here? And this means, let me graph you a little bit table. All right, so that means I know the area or the probability. Probability is also the area in here. Okay, so I know this area. I go to find the G-score. So this area was 101051. 1051. Okay, so I need to read the G-score. So this is reading table backward, all right? So reading table backward, what do you need to do? You need to go to find in the middle is upon 01, I already forgot the number, 1051, 1051. So you have to a little 1051 right here. So if you go to look at these two right here, these three, okay, those are the one that is close to 1051, but I do not have an exact answer match in here, right? If I use this one is too less. If I use this one is too much. So if I look at this one, this is the closest one, okay? So 1051. So if you use this one, is only 0.0005 different, right? Compared to the 0.1051. If I use this one, that'll be even much more different if you take an absolute value, okay? If you take the absolute value for this one right here, it's also much more different in here. So what I mean, take an absolute value, let me show you. Just do a little bit manual calculation so you know what I mean. Okay, so our 1051 minus 0.1056, right? This one, the difference here is only 0.005, okay? If you go to using 1051 minus 1038, all right, take a, so this is 38, so that's, oh, this is 34, another 4 decimal point. Okay, so that's 0.013 different. So you can see this different is bigger than this one. This is a smaller one. Okay, this is smaller. All right. So that means this one is closer to this number. If you go to using 0.1051 minus 1075, this difference is even bigger. Okay, that's 0.0024. Okay, so this is the largest one. All right, we want to choose the smallest one. We want to choose the smallest one. So this one is the good one. Okay. All right, even we don't have so we estimate, we don't have an exact match. So this one is negative. Now you read the G-score on the side, right? G-score will be negative 1.2, and then using the middle one here, negative 1.25. Okay, so you can see reading the table backward is a little bit harder, right? First, you have to go to look at all these middle one, find a number, but you also have to compare to the left, to the right, and then you choose the right answer. Okay, so my G-score here is negative 1.25. Okay, so that's using the table. Doable, but just a little bit, sometimes it can be a little bit tedious that way. That's it. All right. So let's see how do I using the technology to find a table, to read a table backward. Okay, so we will go to using second bus, which is the distribution. All right. And then we're gonna go to, so you have to hit second first. The first time I didn't hit the second high enough, so it didn't show the distribution. Okay, so we're gonna go to the distribution, and then we're gonna using the inverse norm, inverse the normal distribution. Okay, so this one is a really good one to read the table backward. All right, inverse norm. Okay, you go to hit the second bus is using the distribution, and then using this function, inverse norm. And you just need to type the area area is 0.1051, okay? And you get this mu and sigma, everything, unchanged. This is a little bit newer version, so you have a area to the left in the center, in the right. Some of the older model of the calculator, it didn't have this, left, center, or right. The default is always on the left, okay? And then we're gonna pass there, and then you hit enter again. And this is your estimate G-score. Look at it, very quick and easy. So you round to 2 decimal point is negative 1.25, right? Exactly the same. Okay, let me show you one of the older version of the calculator so you know what I'm talking about. If someone has the older version of calculator, let me see if you can find out. Where's my older version of the calculator? Hold on. I didn't unzip that one. Okay, I just want to show you if you have a really old calculator still work, right? But a little bit different interface. So not everyone will have the, the nice looking modern one. So this is a very old TI 83 calculator and still work. Okay. So I go to his second valve. That's the distribution, right? I have a normal PDF, so I hit enter. Look at that, when I hit enter, I don't have anything in here, okay? I don't have an interface as I have earlier, but I can just type a 0.1051 and hit enter, and the default, this default is always area to the left, okay? And I can, not a normal one, okay? Let's try it one more time. Inverse norm. Inverse norm. All right, number 3, inverse norm, 0.1051. Okay, and then I hit enter. And it can still give you the Z-score, okay? Negative 1.25, okay? It's a still function where. So that means you don't have to buy a new calculator, okay? You don't have to buy the new calculator. It still work, all right? It's just you don't have a nice interface, but it still work, okay? This is only giving you one choice. It's always area to the left, all right? So I just want to show you this one so you can see the difference is the interface, right? If I hit the inverse norm in my newer one, I have this area is in the left or in the right, or to the left, to the right, or in the center, right? So this is got more choice. But the simple calculator, you only default is always to the left, okay? And if you want to calculate the center or to the right, you have to do a little bit more work, basically. All right, but it still work, okay? All right, let's move on to the next one. Okay, so this will be negative 1.25. All right. Okay, the expected value. Okay, so what is the expected value? Actually, it's expected value. The expected value is the same as the mean. Okay, if you go to look at this key formula in here, what is the expected value? The expected value in here, look at this one. The expected value E of X is equal to the mu, equal to this mu. All right. So if you want to find the expected value, it's the same as finding the mean for the district distribution. All right, we have to set up a table and then using the x times this probability of x. Okay, so that is this one right here. The expected value, an expected value of the zero means average money gain is equal to average money spent, representing break even. That's exactly the right answer. Okay, means break even, the expected value, the mean. All right. If you have an expected value is positive, that means you gain. If you have an expected value is negative, that means you lose. Okay, that kind of thing. So that's and then the zero means break even. All right. But that's the formula that you can calculate. This is the formula you can calculate expected value, right? I'm sure if you do some of the homework already, you should have that. All right. And I also have another review video last semester using a different using a little bit different question for the review. Okay, that's sometimes when we're still doing the paper test, but the content is the same. So if you go to the announcement, okay, if you go into the announcement here, let me show you where do you find the previous video. All right, this we have a unit 1 review. You have a virtual class, unit 3, right? Unit 3 review. Okay, I still leave this recording in here. Unit 2 review, test 3 review. Okay, part 2, test 2 review, test 4 review. Okay, unit 1 review video, probability video. Okay, so that's it's already passed. And then test 4 review. Okay, or test 3 review. Here's a test 3 review in here. All right, chapter test 3 review. So you can go to look at some of the previous. There's one right here, the unit 3 review video. All right, so that is this one. It's still the same content. This also showing you some of the calculator on how to use that. All right, so I would recommend you, to go ahead also watch that video as well. That's why I keep this one in here. Okay. All right, so that is the formula in here. Let's look at number 6. Okay. Find the indicate area under the standard normal curve. So that means that's the bell curve, right? To the left, G-score is negative, and to the right, G-score is positive. Okay. The total area. So this one, you want to find the total area to the left and the area to the right. Okay, so what do you do in here? You will need to, actually this to the left, to the right area will be the same. When the G-score is the same, it's just positive. One is positive, one is negative, right? Because you can go to read the table in here, negative 2.26, negative 2.26, negative 2.2 in here, 2.26 right here. Okay. All right. So what I mean in here is, this is number 6. All right. So we have this bell curve, right? And then this G-score is negative 2.26. And then of course we have a G-score is 0 in the middle, positive 2.26. So when these absolute value are the same, these two tail, we call this is a tail. This is a left tail, this is a right tail, right? Like a right hand side, a tail. All right, this is a left tail. Okay. All right, this two area is the same. Okay, area is the same. So this area negative 2.26, this is 0.0119, 0.0119. This is also 0.0119. If you don't, you can still go to calculate. Okay. But what's the total area? So the total area, you're using A1 plus A2. Okay, so this is your A1, this is your A2. So, or you can just multiply by 2. Okay, you add yourself is the same thing as multiply by 2, right? So that's A root 2 0.0238. Okay, so if you know this character, you will really easy to find the total area. Okay, under the area, under the normal distribution to the left of the z-score. Okay, so you have to go to read what is the z-score to the left. H2 z-score with z-score to the left. Okay, so for some reason, area under the normal. Okay, so for some reason, this one did not show the z-score. All right, so this should be something like that. Should be something like that, giving you a z-score in here. Okay, because this print out, some of them probably, print out from the MindMap method. So some of them got shrunk that way, got cut off. All right, so this is, I'm gonna just say this is z-score is negative 3.1, negative 1.32, right? So how do you find the area? So is it a distribution area to the left? So area to the left is very easy to find. You just read the table. The table is area to the left. So when we're using the z-score is negative 3.12 as an example, right? So you go to look at the negative 1.3 right here, and then 1.32 will be right here. Okay, so that's 0.09 on 0.934. Okay, all right, because I cannot see the z-score in here. I'm gonna just make up this z-score in here. Okay, so that's the area to the left. So your area to the left is really easy to find. It's just using the area, reading the table. Okay. All right, let's look at number 7. Using the normal distribution of SAT critical readings score for which mean is 5, 0.8, standard deviation is 125. Assume the variable is normally distributed. Okay, so that means we can using the table that's normal distribute. Okay. What is the percent of SAT score gonna be less than 625? Less than, so what does less than mean? Less than, that means the area to the left. If it's more than or greater than, that means the area to the right. Okay, so less than is area to the left. All right, so let's see. We can make a table in here. All right, so this is the X value, not a z-score yet. Okay, so we have an average here is what? Average is 508. Average. Okay, standard deviation is 125. So we want to find this is less than 625. So 625 will be somewhere right here, right? So less than is the area to the left. Look at that. This whole thing are less than 625. So we said that earlier, if you want to read a table, you have to convert the X value into z-score, right? And then this z-score is using X minus mu over sigma. It didn't tell you the n. So the first one, the A1, n is equal to 1. If you didn't tell you anything, n is 1. The second one, n will be 1,000. Okay, so you have 1,000 SAT verbal score and randomly select. How many of them were expected greater than? Greater than will be area to the right. Okay. All right. So the second one, n will be greater. N will be 1,000. The first one, it didn't tell you the n. So when it didn't tell you the n, usually it's just 1. Okay. All right. So n is 1. You don't have to divide by square root of n. So that's exactly how you calculate. So you have a 625 minus 508 divided by sigma, right? And then we round to 2 decimal points. So just a little bit calculation, okay? All right, so we have a 625. Okay, since I forgot a parenthesis in the numerator, so I'm gonna hit enter first. So that way I don't have to use the parenthesis. And then I just using this answer divide 125. Okay, so it's 0.94. Round to 2 decimal point because that's how we read that. Okay, so the area to the depth, just reading the table. All right, 0.94, 0.9 right here, 94 right here, right? So it's 8264. So about like 83 of them, approximately 83 of them will be 83% of the score will be less than 625. Okay, so if you can test 630, which is above 625, right? So anything above 625, you are in the top like a 17th percentage that way, right? So that is how you can calculate this one right here. Okay, so that is the first one in here. That is the first one, right? The first one. The second one here, you want to select, and then this one will be greater than 525. Okay, and you're still using the mean and the standard deviation from the previous one. Okay, so your mean and standard deviation is still the same. Okay, so the B here, N will be 1,000. All right, and then you drop another bell curve. All right, your mu here is still 508. Your sigma here is still 125. And then this time you want to find that is greater than 525. Okay, 525. So it will be on the right. 525. Greater than is area to the right. Okay, so I cannot find the area to the right directly, but I'm going to find the area to the left first. Okay, so this is the area to the left. And my area to the right will be using 1 minus area to the left. Okay, all right, so just pretty much repeat the process in here using x bar minus mu over sigma divided by square root of n, because this time your n is 1,000. All right, so that's 525. Okay, if you want to put everything all at once in a calculator, you do need a parenthesis. Okay, if you don't use the parenthesis, your calculator gonna be interpret as 525 only, and then minus, if you don't use the calculator, that's how the calculator will think using this one. And then if you do not using this whole thing in a denominator, the calculator will think this one and then divide by 1,000. If you don't use the parenthesis for the numerator and denominator, that is how the calculator will think. Okay, and then you're gonna have a z-score is over 500 in here, and that is not right. Okay, all right. So make sure you use the parenthesis in math very carefully. That's why some student told me before, I said, I got everything right. And I said, yeah, you do got everything right, but you didn't use the parenthesis when you do the calculation. Okay. If you calculate have a this showing you um Okay, if you calculate have a list, which is kind of very hard to find, right? Have a this kind of format, okay? You have to go to find this kind of format. If you have a this kind of format, you don't have to use the the parentheses because it separates the numerator and denominator vertically. All right, but not all the calculator will have a this function. And actually, if you go to find that one, is kind of tricky. Sometimes you do not know where to find, right? So it will be easier to just using the parentheses. Personally, I also just using the parentheses, so it's easier. I don't have to find this vertical bar. All right, so um, all right, so you have a G-score, which is 4.3, which is above 3.95 we have in a table, okay? So what do you do in here? Let's go to look at the table, okay? I have a 4.3, which you look at it, this is only the highest G-score going to 3.49, 3.49 in here. Okay, I don't have anything is more than 3.5 in here for the G score. All right, so because you can see the bell curve character, right? This bell curve, the majority is in the middle. All right, this curve can go really, really long, but the majority is in the middle, right? This can go really, 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 really long. All right. But when it's 3.49, 3.49, okay, your area to the left is already 0.99998. Okay. We said the entire bell curve area, total area is 1. So that means you already have a 999 in here, okay? Even this G-score literally can go to infinity, okay? This can actually go to infinity, but the area will be so small. So if we have anything G-score is greater than 3.49, we're gonna just use this number to represent, okay? So the area to the left will be 0.9998. All right. And how much is my area to the right? Oh, it will be 0.0002. Okay. So that's really small already. All right. So that is how you find this one in here. Okay. If you select 1,000 greater than 525, okay, 1,000 of them, not one. You can compare to, if you just one, how much is that, right? So n is greater, n is 1,000. That's how you do that, 1,000 in here. Okay, so that is the percentage, okay? The percentage. This one, that's using the percentage in here, right? Okay, the area on the city region. Okay, so how do you read this table in here? This is the area, okay? So that's the area. That's the area in here, and that's the G-score. G-score is positive 1.05. So this is the area to the right, right? So if you go to read the G-score, it's only area to the left, okay? So you will need to using 1 minus this area to the left. So 1.05 right here, 1.05. Okay, so that's 0.84, 0.8431. So area to the left or to the right will be 0.1 minus 0.85. 3-1, and you can go to calculate this one using the, this would be 1, 4, 6, 9, I guess. You can do the calculation a little bit, okay? So that is reading the table. So not every question will be a lot of calculations. Some of the questions just reading the table, right? And do a little bit addition or subtraction, okay? Determine whether the probability is the distribution is a probability distribution. Okay, so we said earlier in chapter 4, in order to be a probability distribution, you have to satisfy 2 conditions. Okay, condition number 1, all the probability has to be greater than or equal to 0. Let's try this way. Probability is always greater than or equal to 0, less than or equal to 1, right? A probability is always using a positive number or 0, maximum is 1, right? And the sum of all these probability add up together has to be 1, okay? So in order to be a probability distribution table, you have to meet these 2 conditions. So first, let's look at is everyone greater than 0 and less than or equal to 1. Yeah, this is all positive and also less than or equal to 1. So condition 1 is satisfied, okay? Condition 2, you do have to check. Okay, so how do you check? Condition 2 is not very obvious, so you have to check. The checking this one right here is using the sum 1/4. This is probability, right? Plus 1/10, 125, 120, 3/5 plus 1/100. All right, and we need to go to check to see is this one exactly equal to 1. Cannot be less than 1, cannot be greater than 1, has to be exactly equal to 1. Okay, so if we use the calculator, some of them might get a decimal point, right? But I guess this is 14. Yeah, this is, it can all run to, like I said, this is point. This is can get an exact answer actually, even with decimal point. This is 0.1. This one is 0.04, I guess. 0.05. This one is 0.6, right? And then this one is 0.001. Okay, so you're gonna go to add all of this together, and my guess here is this exactly equal to 1? These 2 big one together here is 0.85, right? And then this is 0.109 plus 0.01, and these 2 together, that is 0.11. Okay, so I guess this is less than 1, okay? 111. So that is 0.96 actually. Okay, it's less than 1. It's not exactly equal to 1. All right, so since it's not exactly equal to 1, it's greater than 1 or less than 1. That means it's not a distribution. Okay, it's not a probability distribution. So you can go to find the correct answer from here. Okay. The answer will be no, right? And then you can go to choose which one is better one, because some of the probability has a value greater than 1 or less than 0. No, none of the probability has greater than 1 in here, okay? So the total probability is not equal to 1, so that should be the correct one, okay? Because we just add a sum. The sum is not equal to 1. Okay, so that's the 2 conditions you have to satisfy. Okay, number 10, since this one is not in an ascending order, so you can see, that's chapter 5, and then this one is chapter 4 again. So you really have to kind of just read the question and then to see what you ask about. Okay, I'm gonna go ahead do the 11 first, since we are doing the 4.1. It will be easier to just go ahead finish this one, and then we come back to the 5.4 again. Okay, determine the required value for this missing one. okay, to make the distribution as a discrete probability distribution. As we said earlier, in order to be a probability distribution, you have to satisfy these two conditions. It doesn't matter which table you have, okay? So this one right here, you want to calculate the unknown, okay? So that means this whole thing add up together plus this whole thing add up together should be exactly equal to 1, the sum of this, right? And then you can just go to calculate the unknown in here. Okay, so I have a 0.34 plus the unknown plus 0.25 plus 0.14. This has to be exactly equal to 1, right? And then you can go to add all these together and then subtract from 1. Okay, subtract from 1 in here. So that will be 2514, right? 937. Okay, so it's 1 minus this is 0.73, so this will be 0.27, like that. So this unknown one, the probability should be 0.27. That will make this whole table, the probability exactly add up together exactly equal to 1. Okay, so if you understand the concept, this calculation, I think is pretty straightforward, right? Not that difficult. All right, let's look at number 10. Okay, a population has been as 88 and the standard deviation is 18. Sigma is 18. Find the mean and the standard error of the sampling distribution when the sample size is 81. Okay. All right. So if you go to look at the formula in here, let me show you the formula. Okay. This is the formula. The sampling, the mean of sampling distribution, sigma x bar is always equal to the mean. Okay. And the sampling distribution or the standard error, sigma of x bar is equal to sigma over square root of n. Okay, so this one is asking the sigma of the x bar and the sigma of the mu of the x bar. All right. So if you know these two formulas, this calculation should be very straightforward, right? The mu of the x bar is equal to the mu. Okay, and how much is the mu? On the mu here is 88, so this should be 88. All right, so that is pretty straightforward, right? And the sigma of the x bar is equal to the sigma divided by square root of n. Okay, and the sigma of the x, this is 81, right? And then square root of n. And you know, everyone knows square root of 81 is equal to what? Equal to 9, right? If you don't remember that, you can still use a calculator. But 9 squared is 81, or square root of 81 is 9. Square root of 81 is 9. Okay? And then this divide, so this will be just equal to 2. All right, so this calculation is also pretty straightforward, right? Okay, let's look at this one right here. As I mentioned earlier, this review question is not always the same thing as your test question, right? It's randomly kind of appear. The order is randomly ordered. So that's why it didn't really say everything is 4.1 and 5.1, 5.2, right? This is all randomly orderly. Find an area for this one. So now you can see this area is area to the left. Okay, area to the left. You just need to read the T-score. So that should be really easy. Okay, you just go to read the T-score and that's it. That's your area. So everyone should know how to read the T-score by now, right? T-score is 0.66. So that's 0.6 and then 6. Oh, I'm sorry. Go to the wrong one. Should be. Okay, let's see. Undo. Oh, no. That's the notation, not the undo one. Okay. All right. So now you know this is 0.6 and then 0.6. So it's 7454. Okay. All right. Number A, that's just giving you the table. Okay, so number 13 here is use the standard normal table to find the G-score, okay, to find the G-score corresponding to the given percentile. If the area is not in the table, using the entrance closest to the area. If the area is halfway between the two entrances, using the halfway. So that means you have to, if it's halfway, if it's in the middle, you're gonna have to using the average of the left and right to get a middle. Okay, so if it's not in the middle, you're gonna find the closest one. So that's why I always like to use a calculator for this table-based work, because I don't have to consider the average or to the left, to the right. The calculator is always giving you the best value. Okay, so what is P2? P2 is 2 percentile. All right. So what does 2 percentile mean in here? Okay, percentiles, that means area to the left. Okay, when you say P2 is 2%. All right. So this area in the middle, in this one is 50%, right? So 2% will be really small. All right, this is 2%. Okay, 2% or P2. So P2 is a 2 percentile. So percentile is area below you. Okay. So if you have a 70 percentile, what does that mean? If you have a 70 percentiles, this is a 70 percentile. It's 70% below you. All right. So we need to convert it into decimal point. This is 2% is 0.2, right? If you want to have a 4 decimal point, you can add a 2 0 at the end. Okay, so you need to find a G-score. All right, so if I said earlier, if you want to read the table, you're gonna have to read a 0.02 in this middle in here, right? So 0.02 looks like you're gonna have to go to use this 2 in here, right? 0.02, so you're gonna using to the left, to the right. So if you're using to the left, it's 0.0003 different. If you're using this to the right here, it's 0.0002 different, right? So this one is smaller, so it will be negative 2.05. Okay, if you're using the table. But as I said earlier, I like to use a calculator, right? Even a very simple calculator will still work. All right. So when I go to the calculator, I go to second var, which is distribution, using the inverse norm. Okay, I like the inverse norm a lot. All right, because this can really give you the G-score quickly. Area 0.02, right? And then leave everything in a default. That's the standard one. Okay. All right, and then this is area to the left, yes. And then we just hit enter. All right, we have a negative 2.05. Okay, round to 2 decimal point. So that is how you find the inverse norm using the calculator, because sometimes it probably take a little bit time for people to figure out this one, right? So you can use the table, you can use the calculator. It really doesn't matter. Personally, I really like to use calculator, right? Because that way I don't have to go to find anywhere in the middle. Okay, assume the random variable is normally distributed with mean 86, standard deviation is 5. Find the indicate probability. So probability is x is less than 83, right? Less than, that means area to the left. So it's telling you the normal distribute. So that means this one is bell curve. Normally or approximately normally, you can always treat as a bell curve. Okay, so I will need to go to find the G-score first. It didn't mention the n, so if it didn't mention the n, we're gonna treat n is 1, right? X is 83, and then this one is mu is 86 divided by 5. Okay, so we can see this one is -3/5, so that's -0.6, right? Or you can go to look at a bell curve. That's the x. Oh, I'm sorry. That's the mu is 86, and then 83x is on the left. Okay, that's them is area to the left. So you're gonna go to just find the area when G score is 0.6, -0.6, negative, -0.6 right here. Okay, and look at the top one. So you have to go to read the very back one. So it's 27.2743. Okay, so that's your area. Okay, if you want to find the area to the right, you subtract from 1. Okay, the last one here is finding the probability in between. Okay, finding the indicate probability in between, and this is already giving you the G score. So this is basically just reading the table in here. G score is already given. Okay, -2.89 to +2.89. So -2.89, -2.89 right here, right? Okay, let me give you a little bit graphing. G score in the middle is 0. Okay, this is G score, right? And then +2.89. As I mentioned that earlier, this area is 0.0019. Since these two G score are the same, absolute value are the same. Okay, so that means this right tail is also the same as this one. It's also the same as this one right here. And I want to find this empty one, this middle one, right? So the G score greater than this one, that means right here, and less than this one. That means I need to find this middle part. So how much is this middle part? You can use 1 minus 0.0019 times 2, right? Or you can add these two together and subtract from 1. Okay, so that's it. You can do from here. All right, so we can use 1 minus 2 times 0.0, how much is that? 0.0019. Okay, so you got 0.9962. All right, and I think that's it. That's it for all the review. Okay, for the test 3 review. Okay, any questions? I'm gonna stop recording for this one. And then we're gonna have a review for the unit 4. I'm gonna start a recording. So that way you can have a 2 recording, you know where to start and begin if you want to wait the next time to review the okay, let me start the recording in here. Okay, do we have any question in the chat? Okay, any question about unit 3? Okay, as I mentioned earlier, I am going to also record the next unit review. So that way, next Saturday, we don't have a meeting because next Saturday is the last day for the test and the last day for the exam. Okay, so I want you to go ahead and get prepared earlier than wait until the Saturday meeting and trying to watch the video. That way it will be kind of a little bit too late. Okay, so I'm not go ahead and record. Gonna go ahead and review the unit 4, and this will be another recording. So if you want to wait until you finish the test through it, that's fun. Okay, and then watch this video. Okay, so I'm going to do another recording for this one.